This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. To date, the James Webb Space Telescope has reached its final position and has been aligning the 18 individual mirror segments that make up the observatory's primary mirror. This phase has paid off recently as the telescope has returned its first image. Yes, 18 fuzzy star pictures called the evaluation pictures. Okay, perhaps you really weren't wowed by that image, and it might not be as amazing as you were expecting. However, it is a major first step in aligning the 18 mirrors with each other and focusing them. Here's how.
The James Webb Space Telescope team is nearing completion of the first phase of the months-long process of aligning the observatory's primary mirror using the Near-Infrared Camera or NIRCam instrument. As planned, NIRCam has detected the first photons of starlight that traveled through the observatory and has identified starlight from the same star in each of Webb's 18 primary mirror segments. The result is this mosaic image released on February 11th that appears to be random dots of starlight, but is actually light from the same star reflected by Webb's unaligned mirror segments. This simple image of blurry starlight now becomes the foundation to align and focus the telescope so that it can deliver unprecedented views of the universe this summer.
And here's a little more detail on how the evaluation pictures will be used to fine-tune the primary mirror segments.
Well, first of all, the first evaluation images came in the middle of the night, but the team all came in and we gathered and we evaluated whether the camera was working well enough for us to proceed on with the alignment. And as we analyzed those first, photons, if you will, the team was pretty positive that the camera was working properly and the instrument was working properly. So we picked a star that was very bright and didn't have any stars near it that would contaminate the image. We know that the primary mirror segments aren't aligned, so they actually act like 18 separate telescopes, and we expect to see 18 separate images, one for each mirror, that are a little bit blurry at this point because we haven't aligned or focused anything. And so we pointed at a bright star and we made a mosaic. We actually took the near-infrared camera and we took images in different parts of the sky, and then we looked for the 18 spots from the 18 different telescopes, if you will, and we were very excited to find them. And the 18 spots were actually fairly close to each other, so really everything was very close to what was predicted. We've identified which of the 18 spots is which mirror. At this point, we even know which ones are from the wings, and it turns out one of the wings, you can actually see those 3 spots are a little farther over, and that's sort of what we expected. So we've identified all 18 spots, and the next step is to make an array of them, and then we're ready to start what we call global alignment, which is when each of those 18 spots will start to be aligned and focused. And that's sort of the last step before we take those 18 spots and put them on top of each other to start forming a single star going through the 18 separate telescopes. That's the work that will be starting soon. We have now gotten some data looking through focus, and we've been able to see that we don't see any surprises in the shapes of the mirrors that we're looking at. So far so good, but we do have a long way to go.
So the telescope is getting closer to being fully operational, finally. From Florida Space Coast, this is Dawn Meyer for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends and follow us on Facebook. Join us each week for news and information on America in Space.